Telephone wiring. Chapter 5. Our objective here is to understand the wiring methods for our basic telephone wiring systems. As we've learned through our structured cabling, for the most part, everything we're going to be doing is typically using a star method of installation, or creating a star infrastructure. Now, first thing you have to understand is we're going to be doing residential or we're going to be doing commercial. Small businesses will use a small modular systems, which are components that are typically set up on a wall, and we plug into those. Whereas your new construction will, in most cases, run the same way that we run our data networks. You are undoubtedly going to be familiar with your traditional wiring systems. Most everybody's got a wired phone jack in their home. Whether they use it or not is another story. New construction tends to be much more logical. The wires aren't run as in such a chaotic pattern, and they're typically run in more of a small business. They're typically run in a star pattern, whereas your small businesses will typically run in a more chaotic, crazy pattern. Now, small businesses with more outside phone lines and phones will often use the modular phone systems with the microprocessor technology to offer services similar to large phone systems, but on a small scale. Now, such systems will mount on a wall or to an office or a closet area and connect into a large copper cable or even some fiber optic for the outside trunk, typically using a Category 5E. Now, two developments have changed the nature of wiring systems. One, the advent of structured cabling systems and the acceptance of the T568 standards. Two, the FCC requirements that residential phones use at least Category 3 cables for their star architecture. In addition, the Voice over Internet Protocol, or what we call VoIP phone systems, use computer networks with no additional wiring, negating the need for any cabling dedicated to telephone services. The simple 2 or 4 conductor wire plugs or modular outlets and daisy chain wiring typical phone system installations is now common, typically in the older installations only. The inside wiring is all telephone wire that is inside a telephone company's customer's premises and is located on the customer side of what we call the NI, or the network interface or infrastructure. The wiring depends on the type of phone or modular connecting block that will be permanently wired, or a 4-prong type plug. Now, for our existing installations, connecting points between your inside wire and your telephones may be of several different types. For example, here we have a modular jack. Now, the modulars are the most recently installed systems that are connected to the inside wire via a modular system, which are 4 desk type phones, and consist of a miniature plug at the end of the telephone cord and a matching jack on the wall or the baseboard. Then we have a connecting block, which are wall-mounted phones that have a pair of slots and a sliding pair of blocks and a sliding connector or modular plug on the back, and the phone is attached to a connecting block on the wall, which has 2 rivets that fit into the slots and a modular jack that accepts the plug, and it just allows it to be mounted on the wall in that way. There are permanently wired phones where the telephone is connected directly to the inside wire and cannot be unplugged. The connection point is usually a small plastic square box near or on the baseboard by the floor. And then there's the 4-prong plug, which are on some desk type phones, and there's a round or rectangular 4-prong plug at the end of the telephone cord. The plug then plugs into the jack with 4 holes, and telephones that are equipped with these such plugs, and they can just be plugged in or unplugged very easily without having to deal with the tab that goes with it. Now to look at how we're going to install all of this stuff and the codes that are required to make sure that it's all done correctly. All building electrical codes applicable in your state or local municipality require that you must comply with Article 800 of the NEC, which covers communication circuits such as telephone systems, outside wiring, fire, burglar systems. Generally, these circuits must be separated from the power circuits and then grounded. Now, in addition, all these circuits that run out of the doors, even only if they partially go outside, okay, must be provided with circuit protectors, surge or voltage suppressors. The requirements for these installations will be described here. Now, for conductors that are entering the buildings, if communications and power conductors are supported by the same pole or run in a parallel or span, the following conditions must be met. Whenever possible, communication conductors should be located below power conductors. Communication conductors cannot be connected to cross arms. Power service drops must be separated from communication services by at least 12 inches. And then if they're going to be above roofs, communication conductors must have the following clearances. Flat roofs, they got to be 8 feet. Garages and other auxiliary buildings, there are no specifications required. Overhangs, where just no more than 4 feet of communication cable will run over the area at 18 inches. Where the roof slope is a 4-inch rise for every 12 inches horizontally. 3 feet underground communication conductors must be separated from power conductors in manhole or handholds by brick, concrete, or tile partitions. Communication conductors should be kept at least 6 feet away from lightning protection. Secondly is the circuit protection. Protectors for surge arresters designed for the specific requirements of communication circuits. They are required for all aerial circuits, but not confined with a block. A block means a city block. They must be installed on all circuits within a block that could accidentally contact power of 300 volts to the ground, and they must be listed for the type of installation that they're being used. If the grounding conductor must be run directly, the grounding conductor must be run as directly as possible to the grounding electrode, and it must be protected if necessary. If the grounding conductor is protected by a metal raceway, then it must be bonded to the grounding conductor on both ends. Grounding electrodes for communications ground may be any of the following. You can use grounding electrode of any electrical power system, a grounding interior metal piping, metal power service raceway, power service equipment enclosures, a separate grounding electrode if the building if the building being served has no grounding electrode system, then you have to have any acceptable power system grounding electrode that's covered under the NEC sections, a ground metal structure, a ground rod or a pipe at least 5 feet long and a half-inch diameter would be driven into damp ground or damp earth. If possible, to keep it separate, it must be kept separate from any lightning protection as well. Mobile homes without service equipment or disconnect, you must be grounded within 30. You must have a circuit protection within 30 feet, and must have its own grounding. The interior communication conductors. Communication conductors must be kept at least 2 inches away from power or a class 1 conductor unless they are permanently separated from them. Class 1 conductors are enclosed in one of the following. You can use raceway. It can be type AC, MC, UF, NM, or NM cable, or a metal sheathed cable. Communication cables are allowed in the same raceway box or cable with any of the following: Class 2 or Class 3 remote control, power limited fire protected signaling systems, conductive or non-conductive fiber optic cabling, or a community antenna or television system. You'll notice in all of those, we are not keeping any of our communication cables in the same raceway or conduits as electrical power. Before beginning any wiring job, you must plan ahead and determine what types of components you're going to need. There are several standards. Telephone wire, okay, 22 AWG minimum. That is the American wire gauge, and that is the same type of cabling that we use for our Category 5E, Category 6, and Category 6E cabling, or 6A. And it must have at least 4 insulated conductor pairs, which may be colored green, red, black, and yellow, or may follow standard color coding, because a lot of times you end up with your 25 pairs, so you have different color than what we're normally used to with our data cabling. The conductor should have an outer plastic coating, protecting all conductors with a 1500 volt minimum breakdown rating. The bridge or cross connects, the purpose of those is to connect 2 or more sets of telephone wires. Some bridges include a cord with a modular plug on the end, which can serve as an entrance plug to connecting your wire to the telephone company. Modular outlets, which are the jacks that are or the connecting blocks for the modular phones for plugging in the walls. We have fasteners, such as wire clamps, staples, bridle rings, drive rings. It's also important that when we're changing directions with the fasteners should be placed to hold the wire at approximately a 45-degree angle. You do not want to be going 90-degree angles. And to avoid possible injury, do not use drive rings below a 6-foot clearance level. Instead, you should use the bridle rings. You may find several variations for modular jacks. Some attached to the surface of the baseboard of the wall. Some are going to be flush mounted, which will require you to drill a hole in the wall. Okay. The typical fasteners and recommended spacing distances. Wire staples are used to secure cables to structured surfaces. Other types of fasteners are sometimes used and should be installed using these spacing guidelines on table F-3 in your books, also represented here. Next, we want to look at second line installations. Residents often have 2 phone lines installed today, either for the convenience of family members or for the use of a modern or maybe a fax machine or an extra line. The addition of the second line is simplified if the wiring in the house is already 4-wire. Ordering another phone line from a local company will result in the second line having to be added to the network infrastructure. And if four wires are available in the house, you need just to determine that one pair, whether it be the black and yellow, is not attached to the transformer for powering your dial lights, or remove the transformer if it is. Then the black wire attaches to the tip and the yellow wire attaches to the ring of the second line. Most modular outlets are wired with all 4 wires, so if the second pair is connected, then you will use an RJ14 or a 4-wire connector, and then which can be used to connect the 2 phone lines directly to the outlet, which is the connector that we saw just a moment ago. Now, in small office installations, we'll have a larger number of lines and probably more telephones than residential U that allows all phones to access all outside lines, plus boxes for other functions like voicemail, music, on hold, alarm call, and so on. typical installation would be, for an example, in that graphic that we showed you earlier, that had the boxes appearing, such as here. Okay. So there was our different RJ11, RJ14. You'll notice the 2 and the 4 wires, and then here the extra boxes coming in. And as we can see, we have multiple phone lines coming in. We have our line coming in from the D mark, and then our switching boxes here. Now there's a number of general rules for planning and performing our installation. The general rule for planning and performing the installation would be determine where you want to place the modular outlets, likely to be determined by the owner of the structure, because there are no code guidelines for that part of the telephone wiring. Then we're going to determine which type of outlet is going to be used, the best path, okay, where your bridges are going to be placed, okay, tools you're going to be using, and so on. Okay. Next, we want to talk about the installation safety. Okay. And telephone connections may have varying amounts of voltage in the bare wires and terminal screws. Therefore, before we begin the installation, make sure the entrance point of any existing wire is unplugged from the NI where the telephone company provided the modular jack while you're working. This will disconnect any wiring from the telephone network, and then if you're just connecting a new modular outlet for that wiring, you cannot disconnect. Please take the handset of the phone off the hook, okay? And this will prevent the phone from ringing and then reduce any possibility of electrical shock. There is enough electricity running through that wire to cause you some discomfort. Next we want to go over is the testing. So after installing the wiring, the first step is testing it. Lift the handset, listen for a dial tone. Then dial any single number other than 0 and then listen. If you hear a lot of excessive noise or if the dial tone cannot be interrupted, then you have a problem. Attempt to locate it by using the following troubleshooting guidelines. Try unplugging the phone, okay, or try plugging the phone into a different outlet. Okay. Call a telephone company for repair service if you cannot solve it. Check for broken wires, worn insulation. For touch tone services, if the dial does not operate, unplug the wire from network infrastructure. Reverse the red and green conductors. Be sure the entrance plug is unplugged from the NI or telephone company provided modular jack. Attach each component securely to the wall or the baseboard. Run wire to each component, allowing enough extra wire to make electrical connections. Make electric connections and put covers on components. Plug the entrance plug into the NI or telephone company provided modular jack. Plug in telephones and test to see if it's working. If need be, just go back to your troubleshooting guidelines and find out if it's all working or not. We will be building this year a 66 block infrastructure for you guys to practice with. For residential cabling, you'll be following the ANSI TIA EIA 578 residential standard. Key points for this standard are daisy chaining of telephone circuits is not permitted. Instead, each outlet must have its own home run, which is a line running back to the demarcation point, which gives us a star topology. 100 meter length maximum. Two grades of cabling jacks. Distributed devices are specified grades 1 and 2. Grade 1 cabling may be Cat 3, which likely will not be used. Grade 2 must be Cat 5. Cat 5e would be recommended. Grade 1 outlets terminate one 4-pair of UTP cable and one 75 ohm coax cable. Grade 2 outlets can terminate two 4-pair cables. At least one outlet must be provided in each kitchen, bedroom, family, great room, or den and study. It is recommended that one outlet be provided for each 12 feet of unbroken wall space. The 8-position modular jack is the only UTP jack allowed for the outlet, and it must be wired in the 568A configuration. The 6-position RJ11 is not allowed, and additionally, splitting pairs is only allowed with an external adapter and not behind the outlet. The standard specifies a distribution device for each residence. This device is a panel of sorts, functioning as a type of service entrance panel for a telephone company. Other cabling standards, although the standard for residential is 570, this is not the only broadband system available, and we recommend that you use the 570, but you should be aware that there are others. Two other types of systems, one called Firewire or iLink. These are registered trademarks of Apple and Sony. Firewire can transfer a lot of signal, up to 400 meg per second. It does this by both audio and video over the IEEE 1394 link or system. The IEEE 1394 runs over plastic or glass optical fiber or over short distances of high quality twisted copper pair cabling such as Cat 5 or Cat 5e or better. The IEEE 1394, also known as Firewire, is typically used as an audio-video bus for interconnecting devices. It is a high-end entertainment race, or for which digital cameras or computers to form entertainment networks. We can also do it over USB. Is also occasionally mentioned as a networking technology for homes. It can transmit up to 1.5 to 12 meg speed over copper cabling. It can go up to 3 meters. In some cases, up to 5 meters. Home theater installations often require digital connections to a TV, digital video, HDMI, whatever. In summary, residential and commercial telephone systems are very different in both materials and methods. Rules for indoor and outdoor telephone cables also require or are quite different. Planning and testing are primary concerns for any telephone system installation. Residential network systems incorporate telephone service along with computer and television service inside an integrated system. That's it for Chapter 5. Be prepared for a chapter review, of course, and we will see you again for Chapter 6.